Hi, I'm Shivraj, CSE IoT student. In this presentation, I'll be explaining the A-star search algorithm, how it works, how to construct a graph with heuristic, and where it is used in real world. Learning objectives. By the end of this session, you will understand how to build a graph with heuristic value and weighted edges, and execute the A-star search algorithm step by step, and understand its principle like optimality, admissible heuristic, and how apply in practical systems like navigation, robotics, and gaming. Let's see about A-star search. The A-star search algorithm is a powerful pathfinding algorithm used to find the shortest and most efficient path between two points in a graph. It is basically best of both worlds. It takes a Dixisto algorithm guarantee of finding the shortest path and greedy in best first search speed. In simple words, A star doesn't blindly explore. It uses logic to estimate which path is most promising. That's why it's widely used in GPS navigation and game AI because it's smart, fast, and accurate. Let's see example of custom graph. Now let's look at a simple custom graph to understand how A star works. We have nodes such as S, A, B, C, D, and G, where G is a goal state. So let's see about edges and wedges of S to A is equal to 1, S to B equal to 4, A to C equal to 2, B to C equal to 1, C to D equal to 3, and D to G equal to 2. So from this consider, each node also have the heuristic value, which is the estimate cost to reach the goal. S equal to 10, A equal to 8, B equal to 5, C equal to 4, D equal to 2, and G equal to 0. Let's see this exam step-by-step execution. Here's how. A star runs in. Initially, it starts at S, the start node. It computes f of n equal to g of n plus h of n for all neighboring nodes. G of n is the cost to reach that node. H of n is the heuristic estimate. And then choose the node with the lowest f of n value to explore next. And then move the node from the open list to the closed list. And next finally step is continue until the goal G is reached. Let's say example computation. Let's apply it. At the start, S has G equal to 0 and H equal to 10. So F equal to 10, we can get the value. So from of S, we can move to A or B. L- Let's I jump into A. A has F equal to 1 plus H equal to 9. B has F equal to 4 plus 5 equal to 9. So both value are same. So I can pick of A first. From A implies C, G equal to 1 plus 2 equal to 3. H equal to 4 implies of F. That becomes to 7. That's even better, right? So next from C implies to D. G equal to 3 plus 3 equals 6. H equal to 2 implies of F equal to 8. And from G implies G, G equal to 6 plus 2 equal to 8. H equal to 0 to implies F equal to. So C to D, D to T, G or both are same. So our optimal path we found it as S implies A implies C implies D, G implies D with a total cost of 8. Next slide is principle of A star search. Now what makes A star so effective? There are four principles: optimality, optimizable heuristic, consistency, completeness. That's why A star is considered both optimal and complete. Let's see about real world application. A star is used everywhere around us. In GPS system, it calculates the shortest route while considering traffic and obstacles. In robotic, it helps autonomous robots navigating safely around obstacles. In video game, it powers NPC movement, making them look smart, realistic. In network routing, especially in IoT system, it helps optimize data transmission across nodes. Why A star matters? A-star matters because it combines speed and accuracy. It uses heuristic for fast decision making while mathematically guarantee at the shortest path. It's versatile, works in real-time system, and scalable in simultaneous and AI models. In short, A-star is a perfect balance between theory and real-world performance. Limitation of A-star search. It can use lot of memory for large and complex graph because it needs to store all node in a one open list. And this perform heavily depends on heuristic function. So heuristics that say can perform slowly, this is the algorithm. Thanks for watching.